This is how to solve Euler's method. It's one of the BC topics, so none of us know it. The basic idea is it's an approximation for finding f of x. So if they'll give you the differential, and it looks your final will look sort of like a slope field, and you'll ultimately figure out what an approximate y value is based on x. So I'll show you the sample problem. These are the givens. It'll give you your differential equation. It'll sometimes tell you an initial point, otherwise you'll just use 0, 0, and then it'll give you the step, the delta x. So like I said, it's an approximation. So what you need to start at your initial point and figure out the slope at that initial point. In this case, it's just 3 over x, 1, so it becomes 3 over 1, so your slope is 3. Then what I do, sorry, let me focus it. Okay, there we go. You figure out the change in the y value, and it's approximately just equal to the slope times the change in x. And I said the given is your steps, your change in x is 0.5. So you'll know it's just 3 times 0.5. So your change in y is going to be equal to 1.5. You started at 1, 0, and then you're moving your x value at 0.5. And now this y value is at 1.5, so your next point is at 1.5, 1.5. It's just the difference between P1 here. Now this would be P2. Now you have to find the slope of this one. So we already said it's 3 over x, so 3 over 1.5, so the slope at this point is 2. Once again, you have to find the change in y. So I said it's just up here. The slope times delta x. Slope we said was 2. Times 0.5 delta x equal to 1. So now we know the change in y. Again, the change in x is still 0.5. That'll be the same. So 1.5 plus 0.5 is 2. And then 1.5 plus the 1 change in y, 2.5. So that's our second point, is 2, 2.5. Now we find the slope of this point. And remember, it's a slope field graph. So something like this. So each point has a different slope. And then I said the m is just dy over dx, so 3 over x, 3 over 2, 1.5. So we know that the slope is 1.5. Now again we do it, delta y is approximately equal to dy over dx, so 1.5 times delta x, 0.5. That's equal to 0.75, so your change in y goes from 2.5 to 3.25. Change in x is always the same to 2.5. And you would ultimately use this to continue solving until you find the correct y value. So the question will say something like, what is approximately at f is 3.5? What is f of 3.5? And you'll have to solve for the y value. You just keep on doing it till, stupid focus. You keep on doing it till you get the right f of x. And remember, it's an approximation. You can become more accurate by using smaller and smaller steps. So delta x right now is 0.5, and it's just basic calculus. If it eventually became 0, then you would get perfectly accurate results. So I wrote down just a couple, like a list of steps to follow. So the first thing you have to do is you find the slope at your initial point. Sometimes they'll label it as P1 as the initial point, sometimes P0. It's easier for me to think of it as P1. Once you find the slope, you plug it in to find your change in y. Then you add the delta x and delta y to your initial x and y, which is what is either given or at the origin. And then you find the slope at the second point. And then you use that slope to figure out the new delta y. And then you just keep on adding until you get to the end. So just following those steps should explain Euler's method pretty well.